Stan Gibilisco here. I would just like to talk a little bit about radio waves and explain to you exactly what they are. A viewer recently asked me a rather interesting question. Does a broadcast transmitter produce AC or DC, alternating or direct current? Well, a radio broadcast transmitter, and that's what I assume this viewer is referring to, produces a very high frequency alternating current. That alternating current originates at the transmitter and travels down a cable of some kind. And in the case of, say, a standard AM broadcast station, let's just suppose that it has a frequency of 830 kilohertz, or 830,000 cycles per second. That is the frequency of the alternating current that travels down this cable and to the antenna, which is usually a vertical antenna, a tower of some kind, sometimes hundreds of feet high. So what we have then is an alternating current flowing in this antenna at 830,000 cycles per second. That is in the more or less sort of towards the lower end of the standard AM broadcast band. I remember a station I used to listen to, the Minnesota Twins baseball team, on 830 WCCO radio in Minneapolis, Minnesota, when I was a kid. So that's why I picked this frequency. I just remember that was a very powerful radio station which we could hear for quite a long ways away. But the alternating current comes out of their transmitter and flows in this antenna. But when it gets into this antenna, the situation becomes a great deal different than what you expect with an ordinary, say, household alternating current. The ordinary household alternating current is only at 60 hertz in the United States. That is 60 cycles or 60 complete waves per second. In some countries it's 50 hertz, 50 cycles per second. So radio broadcast transmitters produce alternating current, but it's at a much, much higher frequency. But it's more than that. What happens when you allow a high frequency alternating current like that? Actually, this is technically in the so-called medium frequency radio frequency spectrum, part of the radio frequency spectrum called the medium frequencies, or MF. That's where 830 is. What happens is that you get an electric field and a magnetic field surrounding that antenna in a very interesting way. Now, from your physics courses, you may remember that when you have a current in a wire, you get magnetic lines of flux that form circles around this wire. And I'm drawing these circles in perspective so they look like ellipses. But imagine this vertical wire, and then imagine horizontal plane circles, concentric circles extending out, representing the magnetic, or M, lines of flux. Magnetic lines of flux, just like you would find around a wire. If you connect it to a battery and have a direct current flowing through there, you get magnetic lines of flux. But when you have an alternating current, these lines of flux reverse direction. The flow of the magnetic flux goes back and forth and reverses direction. And what that tends to do is produce an electric field, electric lines of flux, all of which are perpendicular to these magnetic lines of flux, or parallel to the antenna. These are electric lines of flux, like you would get around an electrically charged object, except they too are alternating at a frequency of 830,000 cycles per second. So you have these vertical lines of electrical flux, also known as E flux, and horizontal circles or concentric circles of magnetic flux, which produces then a so-called electromagnetic or EM field. That is an alternating electric and magnetic field. The electric lines of flux are always perpendicular to the magnetic lines of flux at every point in space. And then, perpendicular to both of those, the waves travel out from the antenna. The electromagnetic waves travel out from the antenna, and these waves are like alternating force fields, magnetic and electric force fields operating in a sort of a conspiracy to help each other along as the resulting radio wave propagates out from the antenna in all directions, straight out from the antenna, straight towards you, straight towards the right, towards the left, straight back from you, and to a somewhat lesser extent at angles as well. But that's what a radio wave is an alternating force field. It is an alternating force field consisting of electric and magnetic lines of flux. So if that helps you any, that is what a broadcast transmitter produces, this force field. And when that force field encounters another antenna, like the one in your radio receiver, it duplicates the original currents that existed in the transmitting antenna, except, of course, much, much, much weaker currents. So you need an amplifier and a receiver in order to recover the Minnesota Twins playing their baseball games broadcast on 830 WCCO. Good luck to the Minnesota Twins. Sounds like they're doing fair, but not too great right now. Wish them all the best. They're my favorite team. Stan Gibilisco signing off. Until next time, so long.